All right, so today we're going to be talking about parallel and perpendicular lines and their slopes. There's a relationship between their slopes, and we want to discover what that is and talk about using today and tomorrow what we're going to be doing with those parallel and perpendicular lines. So let's go ahead and get started, and let's just see if we can find the slope of these two lines. First one isn't too difficult. That's in slope-intercept form. We have y equals mx plus b, and so the m is our slope. So in this case, our slope is negative 2/3. So if there is an equation that is in slope-intercept form, it's really pretty easy to figure out what the slope is. We can just look at the m value. However, in example number 2, it's not in that form. This is an equation that is in standard form. So we're going to want to put this equation into this form, and we're going to do that by getting the y by itself. So we're going to subtract 5x from both sides first. And so we're going to have negative 2y on the left equals negative 5x plus 8 on the right. Then we want to get the y by itself, so we're going to divide both sides by negative 2. And when we do that, we're going to have y equals 5 halves x minus 4. And so now the slope is 5 halves because it is in slope-intercept form. So we have one equation that has a slope of 5 halves, and the first equation has a slope of negative 2/3. Well, let's, so we want to, in order to find the slope, we want to put the equation in slope-intercept form. And so let's take a look at a line that looks like this. And if we want to find the slope of this line, we could use rise over run. And let's just say I take this point here and compare it with this point here. It looks like to go from one point to the next, I'm going to go down 2, or down 3 and over 2. So that would mean the slope of this gray line is negative 3 over 2. So now let's find the slope of these parallel lines. All of these lines are parallel to the first line. And let's just see if we can figure out what some of these slopes are. Let's take this line first. And if I go from this point to this point, I'm going to go down 3 and over 2, which means this slope has a slope of negative 3 halves. This line has a slope of negative 3 halves. If I take this brown one over here, it looks like maybe there's a point here and a point here, which means I go down 3 and over 2. So this one has a slope of negative 3 over 2. And the gray line looks like it's doing the same thing. Maybe we go from this point to this point, which is down 3 and over 2. And so they all have the same slope. Parallel lines will have the same slope. So slopes of parallel lines are the same. So you want to make sure you have that in your notes. If you have two lines that have the same slope, that means they must be parallel to each other. So let's take a look at different types of lines. Let's see if we can figure out what the slope of this line is. It's kind of hard to determine where it goes through. But let's say it goes through this point, which is the origin. And let's say it goes through, I don't know, maybe this point as well. So that would be up 3 and over 1, which means this has a slope of 3. We could say that's 3 over 1. But then we want to find the slope of these lines, which are all perpendicular to that line. At least they're supposed to be. So, and again, these points, it's going to be kind of hard to figure out where these points line up exactly, but let's say we take these 2 points, like this point and this point. We go down 1 and over 3, which means the slope here is negative 1/3. And that's what would be the slope of these other lines as well. If I pick these 2 points, it's down 1 and over 3. And so they're all parallel to each other. They all have a slope of negative 1/3. But how does that compare to our original line that's perpendicular to them, which has a slope of 3 over 1? Well, you can see that they're flipped. And if this one's positive, then these are negative. And so we would say slopes of perpendicular lines are what we call opposite reciprocals. That means that they're flipped and they're the opposite sign. So, for example, if we have one line that has a slope of 2/3, a line that is perpendicular to that one would have a slope of -3/2. We just flip it and we make it opposite. If one line has a slope of, let's say, -5/2, then if it's perpendicular, the other line is going to have a slope of +2/5 because we switch the sign and we flip the fraction. What if one line has a slope of 5? Well, because 5 is the same thing as 5/1, we would flip it and it would become 1/5. And because this one is positive, we know this one would be negative. So this is going to be a big word that we're going to throw around a lot during this lesson, and that is perpendicular lines are opposite, have the slopes of perpendicular lines are opposite reciprocals of each other. So let's take a look at example number 3. It says find the slope of a line that is parallel to this line. Well, that means we have to find the slope of this line first. So to find the slope, we're going to get the y by itself. We're going to subtract 2x from both sides. So we have 7y equals -2x plus 14. But then we want to get the y by itself, so we're going to divide everything by 7. So that will give us y equals -2/7 times x plus 14 divided by 7 is 2. So that means the slope of our original line is -2/7. And if we want to write an equation of a line or find the slope of a line that's parallel to this one, they have to have the same slope. So the answer to this question is going to be that our slope is going to have to be 2/7 because they are the same. So what would be the case if we were asking for the slope of a line that is perpendicular to the given line? Well, because this given line is -2/7, if it was perpendicular, if we wanted to write an equation of a line that's perpendicular to this line, we would not use -2/7. We would flip it and make it 7/2. And because this one is negative, this one would be a positive 7/2. So again, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Let's take a look at example number 4. We want to find the equation of a line, or find the slope of a line that is perpendicular to this line. So we are going to start by finding the slope of this line, which means we want to get it in slope-intercept form. So we're going to subtract 3x from both sides. So we'll have -4y equals -3x plus 8. And then we're going to get rid of the -4 by dividing every term by -4. So that'll give us y equals 3/4 x, the negatives cancel out, minus 2, because positive 8 divided by -4 is -2. So that means the slope of our original line is 3/4. But if we want to write or find the slope of a line that's perpendicular to that one, we're going to flip it, we're going to make it 4/3, and because the slope of this line is positive, we're going to make it negative. And we're going to have a slope of -4/3. All right, so now let's just take a look at these two equations. We have two equations here, and we want to know, are these two equations parallel, perpendicular, or neither? And so we know the slope of this line is 3. And so if the second equation has a slope of 3, they're parallel. If the second equation has a slope of -1/3, then they're perpendicular. If it's anything else, then it's neither. So let's find the slope of the second equation here. We're going to subtract 2x from both sides first. So we'll have -6y equals -2x plus 12. Then if we divide everything by -6, then we'll have y equals negative divided by a negative is 1/3 x minus 2. And so the slope of this line is 1/3. So they're not parallel because they're not the same, but they're also not perpendicular because the first one has a slope of 3/1. The second one has a slope of 1/3. They are reciprocals of each other, but they're not opposites. The signs are the same. So they're not perpendicular either. So the answer to this would be that these two lines are neither parallel nor perpendicular. These are the things that we're going to be doing on our homework assignment for today. Good luck with that, and we will talk to you tomorrow in class.